Welcome to the 47th video in our series about Unix tools. In this video, I will show you more about the GDB debugger, but first, let's review some of what we learned in video 46. To print the value of a variable, you can use the print command. To learn the type definitions that GDB knows about, you can use info type to get them all, or you can say info type and then some type like int. And you still get a long list, but it's shorter than the list of all. Even if we say break 13, which was the if statement where we call our function, our program somehow seems to die before that. When we set break 12, which is on the assignment to the variable x, and we do a S for a single step, our program dies on that assignment statement. We learned that on this system, int is a 32-bit value. We learned, using Python, that 99 million is really even. I mean, we knew that, but we verified it. We learned from BC that 2 to the 32 was over 4 billion. And if we have to lose a bit for sign, like signed int, then we should still be able to hold numbers up to 2 billion. And 99 million is much smaller than that. The data should fit. It should fit. It should be even. It's not. The final thing we learned was debugging a C program can cause a big headache. So let's continue the adventure. Here we are, and we say, I just don't get it. What can I do? Unix systems allow you to dump core. And dumping core is a special feature of the kernel. And what happens is, if your program makes some fatal error, the kernel will take a snapshot of the memory and store it in a file called core for you, which you can use later with the GDB. But to do that, your U limit for C has to be set to something other than 0. If we do a U limit, and you want to check your soft core file limit, you can see it's set to 0, which means no core files. Core files can be huge, so I recommend unlimited. And then if we double check again, you could see now core file is unlimited. If we run buggy again, after the segmentation fault, you get the message core dumped. So let's see what we've got. You can see we've got a file here called core, which is a snapshot of the memory at the time that buggy crashed. And to get GDB to look at that, you say GDB buggy and then the name of the core file. And it says, okay, the core was generated by buggy, so we know this is the right core. It tells us that we had a SIG-SEG-V, a segmentation fault, which is correct. And it says it happened in buggy.c on line 12. So we haven't even reached the is-even function. We're dying on this assignment statement. Something is wrong with line 12. And if we print x, it says x is an int pointer and it's pointing inside libc. Wait a minute. We don't want to write inside libc. That's crazy. So our pointer is pointing inside libc, which is not even our code. That's bad news. This means we need to exit the debugger, and now we don't need the core file anymore. Don't forget to delete those. We need to just stare at the code and think hard. This is a technique that they don't teach much at BUU, but they don't teach C programming at all. to the best of my understanding. So that's kind of a shame. Our program is here. And if we look at this, we need to go down the line. No, man. We need to go down to line 12. There it is. And we need to stare at this a long time. 99 million, it will fit in an integer. X is an integer pointer. And we said the thing X points to is this. And we have to stop and think and stare. And if you're really lucky, you will have what we call an epiphany. That aha moment when the light bulb comes on and you say, X is a pointer to an integer, but I have not allocated any memory. And so when I try to use it, it's pointing to just some random location, which in our case happened to be libc. We have to allocate memory for X, and we didn't do it. And that makes us a horrible people. So how do you allocate memory? You say something like X equals malloc size of int. Now that should give us some memory. And if we do this, X should be pointing somewhere else. Now, this could fail. This is not wonderful code, but let's just try that and see what the difference is. So, okay, I have to get rid of buggy and buggy.o to make sure I'm compiling new ones. I don't want any optimization. I want debugging. I need to compile only buggy.o, buggy.c, and I want to put it in buggy.o. And then I need to do my link and repeat the please don't optimize, please give me debugging. Input buggy.o, output buggy. And if I run buggy, I get 99 million is even. Wow. That's actually the answer we want, but we don't understand it. So let's go GDB into buggy. Let's do a quick list. Let's break on line, it used to be line 12, the assignment, but the assignment here is happening on line 13. So let's break on lucky number 13 and let's run. And at this point, let's print X. And you can see it doesn't say anything about libc, which is good news. And if we single step and we say print the thing X is pointing to, and it says yes, X points to 99 million, I'm feeling pretty good. And I can, if I do a step, it's going to jump into the is even function. As you can see, it said so. I'm on line 5 in buggy.c in the is even function, and we did something that nobody should do, which is call our variable the same name as X, but I was trying to show you an ugly buggy program, and this one qualifies. If we print X, you see it's pointing to that same memory, and if we print what's inside of X, we get the 99 million, and when we step, you can see it's going to return 1 because this was true, and we can we could keep stepping, but I'm just going to continue the rest of the program. Everything works. So the problem was that we failed to allocate memory, and we used a pointer without allocating any memory. And then it was a wild pointer, and it happened to point inside libc, and when it tried to write in libc, Unix kernel said, no, you can't write in libc, and he gave you a segmentation fault and killed the program. So we have fixed that bug. Is our program really good? It's better. It's not really good, but it's better. It doesn't crash, it gets the right answer, and we need more testing. But we're out of time on this video. We did rescue the lady from the track before the train hit. The hero did arrive, and who was our hero? It turned out that the debugger let us find the line of code that broke. But we had to use the human brain and stare at that line of code until we understood why. The debugger can often tell you where and when, but it can't always tell you why. Don't lose heart. Keep on trying. The more you do, the more you learn. And you'll learn even more if you come back for our next video. But for now, thank you for listening.